Hello and welcome to this new section on cost reduction and waste minimization in this course, AI in operations management. So in this section, we will give you an in-depth view of how to use AI for cost reduction and waste minimization in operational excellence. And we'll begin by talking about in this section about through lean manufacturing, using the concept of lean manufacturing, how can AI identify inefficiencies in production lines to reduce? Yeah, so let's take a look at that. So there are two parts of using AI for cost reduction and waste minimization. The first is the lean manufacturing approach, where AI identifies inefficiencies in production lines to reduce waste. And that's a classical lean manufacturing model. Second, what it does is it also optimizes energy consumption, where AI optimizes, energy consumption and thereby lowers the operational cost. And this typically will be more useful in energy intensive industries, right? So let's take a look at how does AI identify inefficiencies in production lines to reduce waste first. So, AI identifies inefficiencies in production lines and reduces waste, right? By analyzing, continuously, real time, the historical data. So it analyzes the real time as well as historical data. And that it does to primarily detect bottlenecks, predict failures, and optimize workflow. Now, how does all this work? Let us take a look at the things in detail. So, how AI identifies inefficiencies in production lines? Let us take a look at that. So, the first thing it does is, it does what is called real-time data collection from machines that are IoT and AI. And it collects data on sensors, on equipment tracks like temperature, vibration, output rate, energy usage, and idle time. So it collects the data from sensors on the equipment to track these things, right? Temperature, vibration, output rate, energy usage, and idle time. Then the AI analyzes these streams to flag machines running below optimal efficiency or heading towards failure. An example of that would be if AI detects that a press machine slows down slightly every 4 hours, that could be a sign of overheating, right? And hence, there could be a possible issue later on. So that's what you do by real-time data collection from the machines, from AI, IoT and AI. Then you can also do computer vision to spot defects and blockages. You can use cameras in AI models, to identify defects in assembly or packaging, misaligned parts, or bottlenecks in conveyor belts or robotic arms. A good example of that would be an AI model that spots that 5% of the parts are being misaligned due to a faulty robotic gripper causing downstream jams. So can be done. That is what can be done to use computer vision to spot defects and blockages. Then you can optimize the production flow using machine learning, where you can use historical models to model task duration, worker movement patterns, and material flow rates. So AI can be used for that. And the machine learning can find patterns like which processes take longer than expected, where raw materials is frequently running out, and how many reworks were needed. And an example of that would be if this system identifies that the workers are delayed waiting for material, suggesting keeping a buffer for the materials for the workers to continue to work. Then you can do predictive maintenance to prevent downtime. Machine learning models can forecast when a machine is likely to fail based on historical breakdown patterns. right? Sensor anomalies, and usage intensity. And the, the consequence or the result of that will be AI alerts for scheduled maintenance before machine breakdowns, reducing unplanned downtime and scraps. Then you can also do waste pattern recognition. AI can identify scrap rates, right, by shift operator machines. It can also look at high variance in material consumption and excess energy or chemical use. And say, for example, a thing that AI would be doing in this case would be to detect that one production line wastes more material during night shifts, prompting a training review. So that's how it can recognize the waste patterns. Then it can also use digital twins for simulations and optimization. AI powered digital replicas of the production line can allow testing changes where virtually, you don't have to physically do the changes, test it. And also it can optimize scheduling or layouts or identify hidden inefficiencies without disrupting operations. And that's the benefit of using digital twins. A good example of this would be, simulating running line B at 90% speed to see if it reduces energy use without sacrificing the output. Because if you were to do physically, you would have breakdowns and you could be sacrificing the output. But simulating it through a digital twin gives you a lot more liberty in testing whether the 90% speed can be run. Then you have KPI dashboards and root cause analysis done. AI aggregates data and visualizes, right? What does it aggregate and visualize? Cycle time trends, throughput versus capacity, downtime reasons. And you could, as a result of this analysis, you could find that it could highlight top three reasons for delays: tooling setup time, operator shift changes, and sensor faults. So that's how the KPI dashboards and root cause analysis help. So what will be the result? So result of all doing all this would be a leaner, smarter, and waste-free operations that will have reduced energy, material, and labor waste, smarter scheduling and resourcing, so uses lesser time, proactive machine care and uptime, so that you have lesser downtime, the lower defect and rework done for better output, and increased overall equipment effectiveness. How well is the equipment running in terms of their utilization, especially when the equipments are expensive, this becomes very critical. So what is next? So we will take a look at how to implement such a system that can identify inefficiencies in production lines to reduce waste. So we will look at that implementation of AI the next lecture. So thank you so much for watching this first lecture on cost reduction and waste minimization. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions, and do download the PDF file to take a look at anything that you need.